Assalamualaikum and hi everyone. Today we were going to do a presentation under the topic Vector and Scalar in Architecture. Let me introduce our team members.
Hi, I'm Huda, matrix number 08DEU22F1016.
Hi, I'm Amira. My matrix number is 08DEU22F1099. Hi, I'm Ayuna Bila, matrix number 08DEU22F1078.
Hi, I'm Shahira. My matrix number 08DEU22F1062.
I will give you an explanation of introduction of vector. A vector is a physical quantity that has both a magnitude and a direction. Geometrically, we can picture a vector as a direct line segment, whose length is the magnitude of the vector and width an arrow indicating the direction. The direction of the vector is from its tail to its head. And now I will explain to you introduction of scalar. A scalar, a physical quantity that is completely described by its magnitude. Examples of scalar are volume, density, speed, energy, mass, and time. Other quantities, such as force and velocity, have both magnitude and direction and are called vectors. How about the difference between vector and scalar? Let me explain to you. A scalar quantity is different from a vector quantity in terms of direction. Scalars don't have direction, whereas a vector has. Due to this feature, the scalar quantity can be said to represented in one dimension, whereas a vector quantity can be multidimensional. From the table given below, let us learn more difference between scalar and vectors. So this is a table of the difference between vector and scalar. I will give you an explanation of the characteristic scalar and vector. Okay, the scalar it has only the magnitude, only one dimensional. This quantity change with the change in magnitude. Normal rules of algebra are applicable here. One scalar quantity can divide another scalar. In the example of speed, time, the distance between the point is a scalar quantity, not the direction. While vector, it has direction and magnitude. It is multidimensional. This change with magnitude and direction. There is a different set of rules known as vector algebra. One vector cannot divide another vector, and velocity could be an example because it is a measurement of the rate of change of an object's position.
Vectors and scalars are necessity and widely used in our daily life. It is used in many aspects which involve physics in life, such as engineering, architecture, geography, and navigation. It is also has been used to visualize displacement, velocity, acceleration, projectile motion, military usage, vector in gaming, roller coaster, crosswind, and many more. In this topic, we use vector and scalar to find the angle of a building and area of its surface.
Formula and application. Formula and application. Scalar dot products of vectors. The scalar product or dot product of two vectors a is equal to a1x plus a2y plus a3z and b is equal to b1x plus b2y plus b3z is defined as follows, which is in components and geometrically. Formula for in components is a dot b is equal to a1 b1 plus a2 b2 plus a3 b3, and for geometrically a dot b is equal to magnitude a
multiplied by magnitude B multiplied by cos theta. So the example for scalar dot product, given that vectors A is equal to 2i plus 5j minus 4k and vector B is equal to negative 4i plus 5j plus k. So we need to calculate the angle. So we are going to use the formula, which is in components and geometrically. So first, the solution is A dot B. We are using in components formula. A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. So it will be 2 times negative 4 plus 5 times 5 plus negative 4 times 1. And by using calculator, you will get 13. After that, you need to find the magnitude of A and B. So the formula of magnitude is square root x square plus y square plus z square. For the magnitude of A, will be square root 2 square plus 5 square plus negative 4 square. Then by using calculator, you will get square root 45. And then for magnitude B, square root negative 4 square plus 5 square plus 1 square. By using calculator, you will get 42. And then by using the formula of geometrically, which is cos theta is equal to A dot B divided by magnitude A times magnitude B, which is it will be 13 divided by square root 45 times square root 42. And then cos theta, you'll get cos theta is equal to 0.2990. And then cos sin up, got 0.2990, and then you will get theta is equal to 72.6 degree. So the angle of this vector is 72.6 degree. Okay, so now we're moving to scalar cross product of vectors. So what is scalar cross product of vectors? Given two linearly independent vectors A and B, the cross product A multiplied by B is a vector that's perpendicular to both A and B and thus normal to the plane containing them. The cross product is defined by the formula A multiplied by B is equal to magnitude A times magnitude B times cos theta. The formula is same as the geometrically scalar dot products of vectors, right? Okay, so for the example of scalar cross product of vectors, we are using matrix method. It's the same with the matrix method. So given two vectors, which is vectors A and vectors B, so vectors A times vectors B is equal to ijk, A1 A2 A3, B1 B2 B3. So it's equal to, remember, plus minus plus, so you will get A2 A3 B2 B3I minus A1 A3 B1 B3J plus A1 A2 B1 B2K. And then you cross multiply, you will get A2 times B3 minus A3 times B2I minus A1 times B3 minus A3 times B1 J minus A plus A1 times B2 minus A2 times B1K.
Based on the picture, we can see Leaning Tower of Pisa in Italy. So we want to find the degree of inclination of this building by using scalar dot products of vectors. Given A equal to 4i plus 16j plus 25k and B is equal to 1i plus 9j plus 36k. So after that, we put it on the formula, which is A1 B1 plus A2 B2 plus A3 B3 So 4 times 1, 16 times 9, 25 times 36, so we get 1048. After that, we need to find the magnitude of A and B. The formula is square root x squared plus y squared plus z squared. So it will be square root 4 squared plus 16 squared plus 25 squared equal to 897. Then the magnitude of vector B is square root 1 squared plus 9 squared plus 36 squared equal to 1378. Then to find the angle, we use formula geometrically, which is cos theta equal to A dot B divided by the magnitude A times magnitude B. So it will be 1048 divided square root 897 times square root 1378. The answer is cos theta equal to 0.9426. By using the calculator, you will get theta is equal to 19.5 degree. To find the area of this building, we need to use the matrix method. So vector A times vector B equal to ijk for negative 1, 2, 2 for negative 3. Then vector A times vector B equal to negative 1, 2 for negative 3i minus 4 to 2 negative 3j plus 4 negative 1 to 4k. Vector A times vector B equal to negative 1 times negative 3 minus 2 times 4i minus 4 times negative 3 minus 2 times 2j plus 4 times 4 minus negative 1 times 2k. It will be vector A times vector B equal to negative 5i plus 16j plus 18k. Vector A times vector B equal to square root negative 5 square plus 16 square plus 18 square. By using the calculator, you will get 24.6 unit square.
Vector and scalar are utilized in day-to-day life to assist in the localization of people, places, and things. A quantity that possesses both a magnitude and a direction is known as a vector, while scalar is a quantity that possesses magnitude only. We use vector and scalar quantities daily in our life without us knowing we do. Some technologies apply vectors and scalars in order to make it happen. Without it, our life would be lacking because vectors and scalars have contributed a lot in making life better.
I hope you guys understand our explanation just now.
Thank you for watching us.